Introduction to functions. Determining if a function is one-to-one using the horizontal line test and using the vertical line test. So for a review, a relation is a function if each input value x is associated with exactly one output variable y. So the first test we're going to look at is the vertical line test. And the purpose of the vertical line test is to determine if a relation is a function from a graph. How to use it? We ask ourselves this question: is it possible to draw a vertical line anywhere on the graph of f of x and cross more than one point? And if the answer to that question is yes, then the relation is not a function. So let's take a look at some examples. Which of the following graphs represent functions? If we take a look at this first graph, anywhere I draw a vertical line, for example, here or here, anywhere I draw a vertical line along this graph, it would be impossible to cross more than one point. And so, since we cannot cross more than one point, we would say, yes, this is a function, because every x value is associated with exactly one y value. But let's take a look at this second function. If we look at this vertical line, can we see how it crosses the graph at 2 points? So this is not a function. And the reason it's not a function is because this x value here is associated with two y values. A y value here at positive 3, and also a y value here in the negative direction. If we take a look at this third example, we can see that if we draw a vertical line here, we cross the function in more than one point. And so again, this is not a function because it's not the case that every x value is associated with only one y value. Here we have an x value that's associated with two different y values, so it's not a function. A special kind of function is called a one-to-one function. So for notation, a one-to-one function is often abbreviated like this. A one-to-one function is a function in which each output variable corresponds to only one input variable. So remember that one of the ways we can represent functions is with a diagram called a mapping. So for example, in a one-to-one function, if you have these values for x and the values for y, in a one-to-one function, what you have is every y value being associated with only one input value. So this would be an example of a function which is one-to-one. If you're wondering, well, what would it look like if a function was not one-to-one? Remember, we had a function earlier that looked like this, where we might have two x values that are associated with the same y value. Now, this is a function because every x value is associated with exactly one y value, but these two x values happen to be associated with the same y value. In other words, this y value corresponds with more than one x value. So this is a function, but it's not a one-to-one function. Let's look at some examples from context. If each percent grade earned in a course translated to one letter grade, is a letter grade a function of the percent? So let's think about that. Sometimes I think it's helpful to draw a picture. So the question is the letter grade a function of percent? So here's percent, and here's letter grade. So A, B, C, etc., etc., etc. So percent and letter grade. And so we ask ourselves, if we have a percent, is it graphed only onto one letter grade? And the answer to that is yes. For example, if you get an 84%, you know exactly what letter grade that's going to correspond to. And so, yes, percent letter grade is a function of percent. If so, is this function one-to-one? Well, for example, 84% would correspond with a B. Are there other percents that would also correspond with a B? Sure. And 82% would also correspond with a B. And so it is a function, but it's not one-to-one. Is percent grade a function of letter grade? Well, in that case, here's the question we're asking. Here we have the letter grade, and here we have the percent. And the question is, does each letter grade, for example, A, correspond with exactly 1%? And the answer to that is no. An A could correspond with a 90%, it correspond with a 92%, it correspond with a 96%. So you see how this input value is associated with more than one output variable? So the answer to this last question is no, it's not a function. Now the horizontal line test can be used to determine if a function is one-to-one. How does it work? We ask ourselves the question, can a horizontal line be drawn anywhere on the graph that touches more than one point? And if so, the function is not one-to-one. So for example, let's look at this first case. If I draw a horizontal line on this function, notice that it's possible to cross more than one point. In other words, this y-coordinate, this output, corresponds with, in this case, 1, 2, 3 different x-coordinates. So this is not a one-to-one function. But if we look at our second example, if you draw a horizontal line anywhere along the graph, it's impossible to cross more than one point. So this would be an example of a one-to-one function.